In this video, we are going to talk about the distance formula and how to utilize it, where does it come from, and how we can solve pictures that have a graph or problems that don't give us a graph and just give us a set of points to find the distance between two places. So, first things first is we have to remember our good friend, the Pythagorean theorem, which gives us our a squared plus b squared equals c squared, where our a and our b are just two legs of our triangle. It does not matter which leg we use, but it is leg 1 and leg 2 of our triangle. And our c is our hypotenuse. So it is the longest side of the triangle that does not form the legs. Okay? Next, we have the distance formula, which is just the square root of y2 minus y1 squared plus x2 minus x1 squared. And what you'll see is that this formula is really just the Pythagorean theorem. That is the goal for us on this page. Okay? So let's get started. So first thing we see, we have the graph here. We have a leg and a leg, and our hypotenuse is unknown. So we have 4 and 3 as both of our legs. So I'm going to choose 4 for my A and 3 for my B. And my hypotenuse is going to be that x. It's really good to write out your parts like this, especially since there's so many different parts. So it's really important that we write out our parts so we can see and easily correct if we make a mistake before we plug them into the formula. Okay, I know it's a lot of work, but it's a good habit to get into. So let's plug it in now. So I have a squared, which is 4 squared, plus 3 squared equals x squared. 4 squared, which we can do in the calculator, is 16. 3 squared in the calculator is 9, which still equals my x squared. I can add these together and get 25 is equal to x squared. Now, here is where we get stuck. How do I get rid of this squared? Well, I do the opposite of squaring something, which is the square root. So I take the square root of both sides. My squares cancel, and so I'm left with the square root of 25, which the calculator tells me is 5, which is equal to a single x. Okay? Very good. So now we've done this problem. Okay, we've done this problem, we figured it out. So the next thing to do is to figure out how do you do it with the distance formula. Now, if you notice in this problem down here, we should get the same thing because looking at our triangle, we have 1, 2, 3, 4 blocks. So from 1 to 4, the difference there is 4. And we have 1, 2, 3. The distance here is 3. So notice that it's the exact same triangle. However, we want to use distance formula this time instead of Pythagorean theorem to see how we could do it a little faster. So we need the coordinates of this point and this point because we're trying to find the distance of our hypotenuse, which is x. So this point is located at 1, 5, and this point is located at 4, 1. So next thing we have to do is figure out which one we want to be our first point and which one we want to be our second point. And that does not matter, whichever one you choose, as long as you're consistent. So I'm going to say 1, 5 is my first point and 4, 1 is my second. So my x1 is going to be my x value for my first point, which is 1. My x2 will be my x for my second point, which is 4. My y1 is 5. And my y2 is 1. Now I can plug that into my distance formula. So it's going to be the square root. Make sure you write that. Parentheses. My y2 is 1 minus 5, which was y1, squared, plus my x2 was 4 minus my x1, which was 1, squared. When I do this, I get negative 4 squared. Make sure you bring that square root. I almost forgot. Plus, parentheses, 3 squared. And I like to keep the parentheses because that helps me make sure. When I plug this in the calculator, I get negative 4 squared is just 16, a positive 16, plus positive 9. So then I end up with the square root of 25, which we find out is just 5. So my distance for my hypotenuse is still 5. Okay? And as you see, these two things are the same. Okay? They are the same, which means that the distance formula is really just derived from the Pythagorean theorem. And so we have multiple ways we could do this. So we could have done it 4 and 3 again and counted the side lengths. But this is a little faster way, so we don't have to do as much Pythagorean theorem. Okay? Now, that's when we have a graph. Let's take a look at what happens when I don't have a graph. So this is when the Pythagorean theorem fails us. Okay? I don't have a graph. I can't visually see it. All I have is 2 points. How am I going to find the distance? Well, we're going to do it the same way we just did. So I have point 1 and point 2, and I fill in my parts. So x1 is 1, x2 is 7, y1 is 9, and y2 is 1. I plug it in, so I have the square root of y2, which is 1 minus 9, all in parentheses squared, plus x2 minus x1, which is 7 minus 1 squared. This becomes negative 8 squared plus 6 squared, all in the square root. This becomes the square root of 64 plus 36, or the square root of 100, which is 10. So the distance is 10. And notice, not too crazy, you find your points, you plug them into your parts, then you plug your parts into the formula. Okay, let's do this last distance one to wrap up. So, once again, doesn't matter, let's do the points in a different order. So this time I'm going to do, the first one is 2 and the second one is 1. So my x1 is 5, my x2 is negative 4, my y1 is negative 3, my y2 is 8, and now let's plug in our parts. We have the square root of y2, which is 8, minus a negative 3, so minus a negative makes it a positive, all squared, plus x2 minus x1, so we have negative 4 minus 5 squared, which means I have the square root of 11 squared, plus negative 9 squared. So I end up with the square root of 121 plus 81, which is the square root of 202. And we can leave our answer like that. Okay? Sometimes we leave our answer in the square root just to make it easier for us. So this will be the square root of 202. You could simplify that by finding the decimal, but it's not necessarily needed. And this is how we use the distance formula with a graph and if we're just given points.